Hello and welcome back to the ICND2 journey for the CCNA with me, Ryan. And in this video we're going to continue with VLANs. So there are a few topics in relation to layer 2 VLANs that we need to cover on the CCNA that extends our knowledge that we learned in the CCENT. For those who don't know, you can contact me here on YouTube, on LinkedIn, Twitter, and now on Facebook. So before we continue with this video, let's just review what we've already covered in the ICND1 or the CCENT. So up to this point, we understand why VLANs are needed. We know that they are logical segregation inside a physical switch, and they're normally used for kind of different departments or just breaking up that broadcast domain. We know that there are different ranges and the names of those ranges, i.e. the extended and standard ranges. We know each VLAN is its own broadcast domain and why the benefit of actually breaking up that broadcast domain. And we also know at this point about the access versus trunk. So we know that a single VLAN downstream to a port is considered an access, and a port carrying multiple VLANs are considered a trunk. So an example of this, we know looking at the diagram here that this port will be a trunk because it's carrying both VLAN 6 and VLAN 5 to a router, where no doubt it will kind of route between those VLANs if required and the routing policy allows it. And downstream towards our host are where the access ports are going to be configured. So these are untagged as the traffic is leaving the switch down to the host. So this is what we've learned so far. We know how to configure this trunk using the switchport trunk command, or the switchport mode trunk and the switchport trunk encapsulation .1q. Depending on the switch, you may need to actually specify whether it's .1q or ISL trunking. ISL is outside the scope of the CCENT. It's a legacy way of configuring trunks, and it was Cisco proprietary. The CCENT focused only on .1q. And we know configuring downstream towards these hosts, we would use the switchport mode access and then switchport access VLAN and what VLAN we would like to put them into. And the reason I'm just kind of giving you a review of this is because we need to understand that as we move into our first ICND2 topic. So moving on to the first ICND2 actual topic that we need to cover, and that is voice VLANs. We need to understand why they're needed today and how they're configured and verified. So first of all, voice VLANs ultimately enables us to use a single port for a single user. Now there are some enterprises that don't do this, mainly because they were set up wrong and they've never been changed. But you would literally have your PC plugged into one port, a phone plugged into another port, a PC plugged into one port, a phone plugged into another port, a PC plugged into one port, a phone plugged into another port. And as you can see, if this was a 24 port switch, all of a sudden half those ports are being consumed by telephones. And that's not going to be great, because of course we're going to have to use more physical switches across the network in order to accommodate everyone's needs. So what voice VLANs allows us to do straight away is to use one physical port for one individual user and their telephone. So meaning that this port here would have a phone plugged into it, and on the back of the phone there's actually a built-in switch, and you would plug your PC into that built-in switch. The idea here being is you have one port serving one user, both their IP telephony and their end user's desktop device. So that's pretty straightforward. Now you're probably looking at this diagram and instantly thinking, based on your CCENT or ICND1 knowledge, that this up here is a trunk, and you'd be right in thinking that because you can see multiple VLANs are being passed along this cable. But you'll also be thinking these downstream ports towards the clients are also trunks, because they are also carrying multiple VLANs. But as we know that the best practice down to clients should be access, because we want traffic to be untagged and we only want a single VLAN down to the actual client. Well, in this case, we go against that grain because there's actually two devices on the end of this switch, which is of course the phone and the PC. So as such, we need to think a little bit outside the box here and configure these ports a little bit different, which is why they get the whole category of Voice VLANs to discuss. Now, I've put here, do we use trunks? And I've put in brackets kinda. And the reason for that is because in the past, that's how we used to do it. So before Voice VLANs were an actual thing, before they became actually syntax inside the iOS, syntax that we will look at shortly, they actually were configured as trunks. So on this port here, downstream, you would go ahead and configure the switch port mode as trunk, and you would allow two VLANs on that, VLAN 5 and VLAN 10. And normally what you would do is actually tell the phone any traffic that a user using the phone sends to me, I want you to tag the traffic with VLAN 10, and any traffic you receive from the PC as it comes in, I want you to send it untagged in the native of 5. So what you're left with there is a trunk port, and that trunk port having two allowed VLANs, which is the native of 5 and the tagged of 10. And as it comes in, we're able to actually put the traffic into separate CAM tables, into different kind of MAC address tables, and we're able to segregate that traffic at layer 2. And we're also, because we're tagging the voice VLAN, remember we've got the .1q header, but if you remember back, inside that .1q header, there's actually some extra bits, and those extra bits can be used for something called class of service, which is quality of service at layer 2. What do I mean by that? Is ultimately, as this traffic is sent in VLAN 10 upstream and it hits this switch can ensure that, let's say, 10% of the upstream trunk is used for the actual telephones, and in turn ensures that the telephones are always getting the best quality and that reserved bandwidth throughout the network. So that's quality of service. I don't want to go too far off scope there, but ultimately, what do we need to know at this point? Yes, in the past, before the voice VLANs existed as they do today, we configure trunks downstream and we allow the two VLANs upstream into the switch. We allowed us to have a single port, which single user, and we used those trunks for security and QoS. So next topic, next point, why different VLANs? So just as I mentioned, having that different VLAN means we can put different quality of service policies against that traffic. So for example, another policy could be, as you receive traffic from the phone, ensure that you process VLAN 10 before you process VLAN 5, to ensure we get the low latency queuing in order to make phone calls quickly, and to ensure that it's prioritized if this user down here was also downloading and utilizing their port. And security is really important. So as we actually see, the phones in this instance are in a different VLAN, and that's because if we actually had a PC and you connected that PC into VLAN 10 and you performed maybe like an attack, let's say you filled up the CAM table so it became like a hub, then what would happen was the switch would start forwarding all of the phone calls out of every port, and you could be sat here on Wireshark listening to all of those phone calls, because in Wireshark you have the capability to capture these packets and to put them back into the original format of the phone call itself and listen to that phone call. So it's important that we have the correct level of security, and the first step against that is ensuring that our voice traffic is separated from our data traffic, and in turn, by doing that, it sets us up very nicely to add some level of quality of service, which is called class of service, which is what Cisco calls their layer 2 quality of service. So quite a few things there that we talked about, but the main thing to take away is the understanding of why voice VLANs are needed and how they kind of challenge our existing understanding of trunks and access ports. So how do we configure and verify them? Pretty straightforward, very easy actually. This is an example of a port. We can see that under the interface configuration of Fast Ethernet 01, I've set the mode as access. So again, at this point you're thinking, hang on a minute, if we're having 2 VLANs, surely it needs to be a trunk. And that's how it used to be done. But now Cisco out these voice VLANs, they actually give you a different syntax. So the downstream to all of the phones and PCs will be access. We put the switch port mode access VLAN. So this is the actual data. So we just do it as normal. But now we have this new command, switch port voice VLAN 10. And that ensures that this access port is actually allowed 2 VLANs. So now you're thinking, well, surely that's a trunk. But this is how it works. You allowed a mode access, 2 VLANs, 1 data, 1 voice. Another method, like I said previously, is you can make this as a trunk, but that's no longer recommended from Cisco. It's just important to know that that is actually possible. And in some environments, it's the only way of doing it. Other vendors do not have the luxury of switchport voice VLAN 10. So it's very simple, because it's ultimately, based on all of our knowledge we know so far, the only difference being is this one command, switchport voice VLAN 10. Now what about the verification of the configuration? Well, just like we've learned up to this point so far, we have this show interface. Obviously we put up in the interface we want to view, and then we look at the switch port. Doing this will show us what VLAN has been assigned to that access port and which voice VLAN has been assigned to that access port. So when teaching this topic, I get asked a few simple questions, and I'll just answer them for you. First question is around kind of the voice VLAN itself and the number. The voice VLAN can be any VLAN. It uses the same VLAN database as your data VLANs, so that's pretty straightforward. It also means that if you're using VLAN 10 for your voice, then any other switch in the network that needs access to VLAN 10, you do need to trunk it just like you do with the data. And if VLAN 10 is used for your voice, you cannot use it for your data. So very similar, it just works the same as any other VLAN, except for you have this new command that you put downstream towards the access. Another thing worth mentioning is, how does the phone obtain the VLAN? So how does it know what to do? Now there are different variations of this. If it's a Cisco switch and a Cisco phone, then we can use CDP, the Cisco Discovery Protocol, and in fact using the switchport voice VLAN 10 will actually signal to the phone about what VLANs it should be using. If it doesn't use CDP because it's not a Cisco phone or it's not a Cisco switch, then you can normally use the LLDP, the Link Layer Discovery Protocol, and the extension for that is the MED, which I think is Media Endpoint Discovery. You might want to double check that, but ultimately this is the open standard of doing CDP. Or thirdly, you can simply just go into the phone itself and set up what VLAN you want it to use. So there are different ways of doing it, different manufacturers offer different methods, and of course you might want to use a different method depending on how you're doing it. So if you've got a large deployment, then you obviously don't want to be logging on to 100 phones and setting the VLAN, so it does vary depending. but as long as you know the high level that the voice VLANs exist and that there are different ways of communicating with the voice VLAN, then you should be good. So it's relatively simple actually when it comes down to it. Kind of the complexity is understanding that this is actually something a little bit different than what we've learned so far, and to understand how it gives us a single port for a single user, how it enables us for quality of service, and why we need it for security reasons. So let's go ahead and get Packet Tracer installed. I'm using Packet Tracer 7.2.1, which is the latest one on the Cisco Network Academy, and that's free to download once you've created an account. You don't need any Cisco licensing or anything, or support contract. So let's get that downloaded and installed. Okay, so Packet Tracer is installed. Let's go to the bottom here. Let's grab a switch, 2960, and then let's grab a piece of an IP phone. There's our IP phone, and if we click on it, it's not that great of a quality, to be fair, even on the application, let alone for you guys on YouTube. But over to the right here, this is a RJ45 port, and it says to PC, and over here it's another RJ45 port which says to switch. So of course normally what we'd do is very much like this, but what we're here for really is looking at the CLI and understanding what it is that we've got configured. So on this port here, downstream, which is FA01, we can set up a couple of VLANs and assign them to the switch. So I just muted my mic there so I can actually type. So we have the Fast Ethernet 01, which is the link downstream towards the phone. We put it in the access VLAN of 5 and a voice VLAN of 10, and it's a access mode. And then I obviously up here created the VLANs so they're actually inside the database. And then when we do the show run interface switch port, we can see straight away the port's enabled. It's been statically set to access, so DTP didn't help us set the mode. Operationally it's down because it's turned off. The trunking is .1Q, native VLAN, and this is where it starts to get interesting. We have VLAN 5 for data, and the voice VLAN is VLAN 10. So to us that's kind of set up correctly, happy with that. And that's what you need to do on a switch in order to enable communication on the phone downstream. Now, why the port is probably operationally down? Maybe it's because I need to put, I need to actually power the phone. The phone's probably not being powered in any way. Maybe that needs to be done. And maybe this particular switch doesn't offer PoE. It doesn't have the show power option, so maybe that's the reason why. But you can go ahead and actually configure something a bit more interesting than this. But as far as sort of the CCENT and as far as the ICND2 CCNA is concerned, that's all you need to be able to do on the actual switch. If you want to know more about the phones and a bit more around kind of what a phone would do, like for example how it would download its config via TFTP or connect to a Cisco Manager Express, a CME or CUCM, Cisco Unified Call Manager, then those sort of topics are outside the scope of the routing and switching and more towards the collaboration. But for now, that's the only commands we need to be aware of as far as the CCENT is concerned. Okay, that's all we've got time for in this video. Hopefully it was a nice quick video to get you into the mood for the ICND2. So moving on then, what did we actually cover in this video? We first of all had a little bit of a VLAN refresher we reviewed what is a trunk and an access port, and then we looked at kind of voice VLANs and applied what we currently know with our knowledge and how using the voice VLAN sort of goes against that in some sense or another. But we also discussed the history of using trunks instead of the voice VLAN command. We, more importantly than the configuration, understood why the voice VLANs are needed. We need to actually allow voice VLANs to enable QoS by giving us a header to put class of service against it, and to also ensure security is met by putting our voice traffic in a different VLAN than our data traffic. We then went through the configuration and verification. Very simple there. We actually looked at creating the VLANs and then assigning them to the access port using the voice VLAN command and the access VLAN command, and then done the verification by looking at the switch port. So we didn't get a phone up and running, but there's plenty of capability inside Packet Tracer to do that. As I said, you can look at actually CM and CME, and you can actually get a phone powered up using the PoE, or actually using a power adapter, like plugging it into an AC outlet, to get some sort of power to that phone and to do some further verification. But that's all we got time for in this video, and hopefully it's been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.